regenerative braking. That is what you have. Only difference. Okay, so that is it. Then beta the discontinuous conduction mode nadi you have is extinction angle. See, that is what you will have, one extinction angle will be there. Okay, so that same you can have. Then dual converter, you can see it is a 4-quadrant drive and it routes the like all 4 quadrants. So this is the dual converter. So you are connecting from motor from 2 full. So this one converter 1, this one is converter 2 connected to a single motor. So dual converter. So operation and all this thing remains same as that of. Only thing is you are changing here RL load, RLE load. You are converting to that. Okay, so the converter 1 so this is there, and then for converter 2 this is there. Then you can see again, so here this is for semi 3-phase semi converter. So same thing, working remains same. You can just go through it. Then quadrant of operation 3-phase that is what. So single phase HMD, then 3-phase is just a replica of an EG. Okay, so that you can go through it. So finally, if you can see, dual converter also it's there. Okay. So this is what you will have. So 3-phase, the single phase fully controlled rectifier, first and fourth. Single phase half controlled rectifier, first quadrant. 3-phase fully controlled rectifier, first and third, first and fourth, and 3-phase half controlled rectifier only first quadrant. So this is how actually single phase and 3-phase controlled rectifier circuits are or looks like in case of it. Then shunt and all this thing also it will remain same. Only thing is like the current and voltage relation differs. Otherwise, the concept remains same. Okay, so the speed control of that. Separately excited shunt, series, and all these things remains. Then series and separately excited are, they are more or less similar. Only thing is, the thing is series where it is a self-excited, whereas shunt separately excited we are giving external supply from the external supply. So therefore that is the only difference. Otherwise the voltage relation, then power relation, and all this thing will be same. Okay, so then next topic for discussion is what Leonard system of speed control means. This is what Leonard of speed control means. You are using, so this what Leonard, you are using some rotating device to control the speed of the machine. So now if you have like what Leonard can become static what Leonard, so you can have static what Leonard. Static what Leonard means then you are replacing this rotating part with the power electronics devices, then we call it as static Watt Leonard system, and then we have discussed it that one above. Now what Leonard done, the conventional method of speed controlling, that is conventional. So you are using something like this conventional method of controlling the speed instead of, so now in static what you can do is you replace this by whole system by the power electronics devices. So this PE devices, then it becomes PE devices such as IGBT, MOSFET, SCR, all these things. So then it becomes static Watt Leonard system. So previously, before the uh, uh, before the introduction of power electronics devices, the speed control of motor were done through this Watt Leonard speed controls. Now we are having. Okay, so again here also same thing you will have is like uh, armature control and then field control only same there. That is what you have. Okay, so this one we will try to see. You can see this Watt Leonard method. So in this case, just this is maybe same as that of the machine one where you have the main motor, then GD. So this motor is the motor whose speed is going to control. Then this G is the actually separately excited generator which from this one given to this. So this can, you can see is, and the motor generator say like when you used to perform the experiment on the open circuit characteristics of DC generator. So this type, and then from there this is coupled to the motor generator of this other one. Okay, so this is what actually is. So now if you want to control this, you can control the field of this and then control the speed of this motor. Okay, so separately excite generator, then E is the exciter, then M type is actually motor driving driving motor. Okay, so that, then potentiometer, then S is the switch. Then if the system is work on the AC supply, then M is three-phase induction motor as shown in this figure. Okay, so this is like whatever is there. Now if it is DC, so working the, you can see, just go through it. The motor drives the generator and exciter at constant speed. So this can be controlled by varying this regulator. Okay, the speed of or voltage feed to this motor can be varied by this regulator or potentiometer. Okay. Then by changing the voltage applied to the motor, it changes the speed. So this is what can be. So detail, it's there, so you can have that. Then the most important or one important feature of this water Arduino system is regenerative action. Means it can work in that fourth quadrant also. Now, if the system is to work on DC supply, first case study it was working on, then motor M is a shunt motor and exciter E is not necessary, because the excitation for generator G and can be obtained from DC main as shown in figure, so it is not necessary. So here, so then this motor M1 M2, so this is there if it is DC Nabiyaji. Okay, so then this can be shunt generator, and then okay, then same thing you can have. So vary this field circuit, and then you can, if you want to reverse the direction of rotation of this motor, then you can just reverse this switch, reversing switch from this. So here you can have is like what you have. So the generator output voltage will be varied from 0 to maximum by reversing the direction of the field current of G with the help of reversing switch. Polarity of generator will be reversed. Okay, so that is what. So if you want to change the direction, you can change this switch reversion. So another thing is, if the load is intermittent, so intermittent load, the slip ring induction motor is employed and flywheel is mounted on its shelf. This modification of Watt-Leonard system is called Watt-Leonard Finger system, which uses a small motor generator set with now additionally flywheel is there in this case. So this is there. So you have this flywheel is there. Okay, so the flywheel is there, and the main function of that flywheel is to reduce the fluctuation in the power demand from the supply circuit function of this flywheel. Okay, so this is what you. Then advantage, you can just go through the advantages. Yeah. Disadvantages, and that is what you have. So this one I have already given you. So now next type of drive you have is DC chopper drive. So chopper can also be used to. So as in the introduction we have seen, the chopper can also be used to control the speed of the electric motor. Then we call it, now if you are using chopper to control the speed of motor, then it is called as the DC chopper drive. Okay, so here the speed control of DC motor can be controlled, and then chopper is used where the available supply is DC, where there is a battery, or if the AC voltage is already rectified, then we use as chopper drive. So mainly the chopper drives are used in traction purpose and in servo and then battery operated vehicles. Okay, so these are some of the applications where DC chopper drives are used. The advantages are high efficiency, flexibility in control, small size, fast response delay, less weight, and regeneration at very low speed. Then the possible control modes of DC chopper drives are, it can be under power control mode, regenerative braking mode, rheostic brake mode, and then combination of second and third mode. Okay, so this is what you will have. So now again same thing you will have. Now only thing is you are connecting here motor load. Okay, so motor load, the working and all this thing will remain same. Then next is AC drive scheme. So introduction to the AC drive. So that one we will continue in next class. And many are not there also. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.